In 2026, some of the world's most crowded cities faced a strange problem. Not a lack of technology, not a lack of money, a lack of space for trees. Millions of people were living inside concrete landscapes, where every square meter already belonged to roads, apartments, parking structures, or data centers. Cities wanted cleaner air, lower carbon emissions, and healthier environments. But there was nowhere left to plant forests. And that's when engineers asked a question. That sounded almost offensive at first. What if we stopped trying to plant more trees and started building artificial ones instead? The result was something called a liquid tree. Not a tree made of metal, not a fake plastic decoration. A living machine. Inside a transparent tank, microscopic algae float through water under carefully controlled light. These algae absorb carbon dioxide through photosynthesis, just like plants. But unlike a traditional tree, this system can be placed almost anywhere, next to highways, on rooftops, outside subway stations, in the middle of heavily polluted districts, where real trees struggle to survive. At first glance, it looks like a futuristic street lamp glowing green at night. But biologically, it is closer to a miniature ecosystem. And surprisingly, some prototypes can absorb carbon dioxide at rates comparable to multiple mature trees, while using only a fraction of the physical space. That single idea shattered a psychological wall. For decades, environmental discussions were built around one assumption: nature and technology are enemies. But the liquid tree introduced a different philosophy. What if technology could compress nature's functions, instead of replacing nature itself? That distinction changes everything. Because cities were never rejecting clean air, they were rejecting the logistical limits of traditional solutions. You cannot plant a forest in the center of a megacity intersection. You cannot wait 30 years for mature trees while pollution rises today. And in many high-density areas, even maintaining normal vegetation has become difficult due to heat, drought, and land prices. So engineers turned to biology itself. The algae used in these photobioreactors are tiny organisms with extraordinary efficiency. Some species grow incredibly fast and perform photosynthesis more aggressively than large plants. In controlled environments, they can continuously absorb CO2 while producing oxygen and biomass. In other words, instead of building bigger forests, humanity started building concentrated photosynthesis. That sentence sounds almost cyberpunk, but it's real. And this is where the story becomes deeper than environmental technology. Because the liquid tree represents a shift in human thinking. For centuries, civilization expanded by separating itself from nature. Concrete replaced soil, neon replaced sunlight, machines replaced ecosystems. But now, the next generation of infrastructure may blur those boundaries again. Future cities might not simply contain nature. They may biologically operate like living organisms. Buildings that regulate temperature through algae walls. Roads that absorb pollution through engineered bacteria. Water systems that clean themselves using microbial ecosystems. Agriculture integrated directly into urban architecture. The line between machine and biology is starting to dissolve. Ironically, some of the people best positioned to understand this future are farmers. Because agriculture has always been biological engineering, farmers already understand invisible systems. Most urban residents never think about water balance, microorganisms, nutrient cycles, sunlight efficiency, oxygen exchange, seasonal adaptation. Rice farming especially depends on the relationship between water, algae, sunlight, and oxygen. A flooded rice field is not just mud and plants. It is a carefully balanced ecosystem. That's why technologies like the liquid tree may feel less shocking to agricultural communities than to tech communities. To many farmers, the idea is almost intuitive. If biology solves problems efficiently, why not scale biology itself? And perhaps that is one of the biggest ironies of the AI age. The future may not belong only to programmers. It may belong to people who understand living systems. Because artificial intelligence can optimize data, but biology has already been optimizing survival for billions of years. Humanity is now trying to merge the two. AI monitors algae growth, sensors track carbon absorption, automated systems regulate light exposure and water chemistry in real time. A machine learning model may decide how a living organism breathes inside a city. That is no longer science fiction. That is infrastructure. Of course, critics still exist. Some people argue that artificial systems can never replace real nature. Others fear cities will use these technologies as excuses to avoid protecting forests and ecosystems. And honestly, those concerns matter. A liquid tree should never become an excuse to destroy actual forests. Natural ecosystems provide biodiversity, cooling, wildlife habitats, and emotional value that no machine can fully replicate. But maybe this technology was never trying to replace nature. Maybe it was trying to bring nature's logic back into places where nature was pushed out long ago. That is a very different conversation, because the future may not be a battle between nature and machines. It may be a fusion. The old industrial mindset treated biology as fragile and inefficient. The new mindset sees biology as the most advanced technology Earth has ever produced. Trees are carbon-capturing machines. Leaves are solar panels. Cells are nanotechnology. Photosynthesis is energy engineering. Human civilization is finally beginning to study nature, less like scenery and more like software. And once you realize that, the liquid tree stops looking strange. It starts looking inevitable, especially in a world where climate pressure keeps rising, populations keep concentrating, and cities need solutions that fit into shrinking physical space. In many ways, this technology reflects the same philosophy that transformed modern Japan. After World War II, Japan could not compete through size, so it competed through precision. Smaller electronics, smaller engines, smaller manufacturing tolerances, more efficiency inside less space. The liquid tree follows a strangely similar philosophy. Condense a forest into infrastructure, not by destroying biology, but by understanding it deeply enough to redesign its form. And maybe that leads to the most uncomfortable question of all. If a machine could breathe better than a tree, would you still call it unnatural? Or would you finally admit that humanity itself has always been part of nature too? Because perhaps the future is not concrete versus forests. Perhaps the future is cities that learn how to breathe.